Thanks everybody for joining another episode of creating a C# API using Clean Architecture. In this one, we're going to be going through a few concepts. The one would be dependency injection, which is a powerful software design pattern used in C# and other programming languages. It enables loosely coupled components by managing dependencies between classes. What it just means you don't really have to create an object every time you use a certain class. You will see an example as we move forward. And we will also get to take a look at how we can add the logic for these HTTP methods that we have already put in here, and as well as try to use a MemCache, which is like a memory cache, which is more like a database that exists within your app that doesn't really persist the data outside the execution or the running of your app. So without waste of time, let's just jump straight into it and get our hands dirty. I'm going to assume that you have already checked the previous videos and you know the basic structure of the app, wherein we said in here, the API, we're going to add anything specific to web APIs and some sort of controllers that we're going to get to expose and anything that needs to be public. And then on the application, we're only going to add logic that is specific to this app that we have. So it's any business rules, any business services, or any business entities that has to do with the cater.todo app. So you've checked here that I have added a file called interfaces, and then there's one CS file that is called ITodoService.cs, and inside it there's just obviously a normal namespace, and then there's an interface that is named ITodoService, right? And then you find another file called or folder called services, and then inside it you just have to do services. So we have the interface and its implementation down here. Don't forget to import the correct namespace so that the correct service or interface is imported. So let's just go and add our first method that we would like to add into our to-do service, right? So for example, let's say we have a method called getToDo that receives some sort of an ID of type string and returns something. We will get to change the type of string to be a to-do details later on, but for now, this is just for you to see what our ITodo service could be. And then if we go to the to-do service, then we go ahead and just implement how we would like these to be. So let's say, for example, in this case, you just want to return something like to do. I think this will give us a small issue. So let me remove the task and just have it as a call like that. Good. So you can see that we can be able to return this, right? So with dependency injection, it allows us to just use this service straight into wherever we want to use it. The way to go about it is you can just go and say ITodoService, and then you can just name it to-do service. I think for now it won't really recognize that because we need to add that project reference here. So I'm going to just say that I'm going to add the to-do application project as a reference into our to-do API project. Let's give it a second for it to just do that. And then now you can move on top, show potential, and then import this. If this doesn't give you an option, you can just go ahead and add your interface accordingly. So with this, this is where you can just say you are injecting your service into a class directly, and that's obviously one of the biggest benefit of dependency injection. And you can just go ahead and then have a private read only, and let me just put an underscore so that it can have a distinction, and then you can go ahead and just say equals to do, and that's it. So instead of you having to use this class and then go ahead and say class, new class, and all those kind of things, create an object, and all this other fancy stuff that we normally do with C#, you now can just go ahead and say, okay, I know there's a interface that will implement such a class. No, there's a class that will implement this specific interface that we are injecting here. Go ahead and then just take its instance from the current execution and then let us use it. But it does not just end here, right? Because the only thing we have done is just to make sure that the I interface and the class knows each other, but then the application or the whole API doesn't so far. So we need to go ahead to program.cs file, and then I'm going to just name this section dependency injection. Make sure that you go under builder dot services, and then you say dot add singleton, like that, and then you put that, and then you say ITodoService, and then to do service like that, and then you can just put the brackets at the end like this. So in this way, your API, when it runs, it will be like, okay, I know this interface has an implementation of this. So I'll just go behind the scene and create some sort of an object that will be running throughout the whole execution, so that whenever you call this interface, we go and call the implementations of specific classes, specific methods from this class. And that's what's just going to happen. So let's go ahead and just call the getToDo method. I know here we really don't want to be doing that, but let's just duplicate this get call. I would like to call it get sample. This is just for us to see this in action, and I'm gonna just let it return a string instead, and then let's say underscore to do service dot get to do. Let's just put a dummy ID, and that's it, right? Let's just see if obviously our project will run, and then we'll come and tidy up a few things just to make sure that we have a proper structure. I'm going to start that. I got the error, or this error, just because there was these two endpoints that are kind of ambiguous. They're both get, and we don't really have a specific path for it. So I just kind of commented out the other one. So if we go ahead and just refresh, then you should be able to see this being able to call and return that thing of to do. Did you see? We just used a class without having to instantiate it. We didn't have to create an object for us to use it because of the power of dependency injection. All we had to do was to add an interface, and then go ahead and add the implementation of such an interface. Then we went straight to the program CS and then add it as a singleton, and we make sure that we match up this interface with its respective class. And then for usage, we just go ahead and call it directly here, and then just make sure you pass it as a parameter on your constructor, and then you assign it to some sort of a local variable within the class, and then you can be able to use it as many times as you can. Now that we have seen that our code runs, let's go ahead and just give a bit more structure to our code. So I'm going to go ahead and just update this class to be a ServiceCollection extension, or you can call it whatever you want. But here we're going to just make sure that the code that we added to the program CS file is extracted from that file and then is put in here. This is quite useful if we have so many interfaces with so many implementation of such interfaces. We probably don't want to be putting that in the main program CS file. So to restructure this class, we go to make sure that it's going to be a static class so that we can have access to its members without any problems. Then we can just do this and then call the first method to be of type I, service collection. Then we can just say add my services or add application services. This is just the name of the method, and then we let it take an instance of the current execution, and then we can let iServiceCollection as a parameter, just like that. And then this is where the magic happens. Then we can be able to just edit the code we added on program CS. But before we do that, let's just make sure this is resolved. So you just go and hover on top of this, and then you will see that it says install the package from Microsoft Extensions, Dependency Injections, Abstraction. I'll say yes. Find and install. Let's give it a second. Went ahead and it did that. So this method, obviously, it's going to give us an error because it expects a type of iServiceCollection being returned. So we're just going to return it like that. And then this is good. But then we need to ensure that whatever that we just did here, I'm just going to copy the whole section and remove it from the program CS file. And obviously I can just go ahead and remove all the imports here like that. We make sure that we move it here. We're just moving. We're not really doing anything complex there. We can just say collection.AddSingleton, and if we had other classes, obviously, then we can just go ahead and, you know, duplicate it as much as we want. But in this case, we only have one service to add. There is many other options. You can go ahead and, you know, put these two interface and your objects together. So you can use something called AddTransient, which follows kind of the very same pattern. And as well, you can use AddScoped. The difference is that AddSingletons add a single instance for the entire application's lifetime, which I kind of prefer that because mostly the services you probably just want to use it all throughout. And AddTransient it creates a new instance every time the service is required. So it kind of, you know, quickly creates an instance whenever you trying to use certain service or a certain interface. And then AddScoped, it creates a single instance per scope, such as an HTTP request. So it will say, okay, for this set session of your HTTP, I'm going to create a single instance of this certain class, which, I mean, there is benefits to that. So if your app really requires such, you know, detailing on how you create your instances, you can go about it. But for simplicity, I just go ahead with AddSingleton. And now we are done. We can just go back to our program CS and just make sure we add this back as a service. Add.services.add application service. 1 second, application service. I'm just going to paste the name there and then obviously pass in the builder. Oh, we don't even have to pass it because we're just referencing it as the current execution. So I don't even have to pass the thing there. So it's using the keyword this. If it wasn't, then I mean, I could have just, you know, passed it there. But it's nicer because it's obviously using the builder pattern. It says, okay, on whatever the current instance we are on, let's just go and append this with a new set of service. And if I go to it with F12, then you can just be able to see the other things that we're injecting. So if we had other stuff, we would just go ahead and add them. So that is it about dependency injection. We'll definitely just go through quickly some other methods we can add to our do service, but you've seen how this will help our app implementation look much cleaner and nicer. Great, we are back at it, and we are about to just add memory caching to our application here. So to do it, I can just say manage NuGet packages and say paste the name Microsoft.extensions.caching memory and click under browse tab. I'll click on the first one. That will just allow me to install the whole package. Let's just say yes to everything. And then here you can see now it's installed. So what this will do to us is kind of create like a small database that only lives within the execution of the app. So every time the app is running, this small database will be able to save and allow us to get and delete and update any information within it. For me, I'm just using this to simulate how we could be getting our data between different calls on our API side. On the next episode, I will definitely show you how to do this using a real database and interface and entity framework within C#. So to go ahead and register this MemCache, I can just go and do this. I think I should be able to do something like AddSingleton and then memory cache, and then just say memory cache like that. I think I know one way you could go about it. It's if we go straight to our program CS file. I think it should be, obviously this is like this is like option 2. You should be able to say builder dot services dot add memory cache, and this will behind the scene definitely just do what we just did the other side for us, but I like the old style way, right? So let's add it like that because I only want this to be added within this one ServiceCollection. Before we move on, I would like to just move the model straight into our application like that. And this should be having the correct interface. And then we save that. I'm sure that will make a few things fail. This doesn't exist there anymore, so I would like to use it from this side, and then I can go ahead and delete that. Our app shouldn't fail, so let's just try to rebuild it. Good. So now we have moved our to-do details to the to-do application class library, and then now let's go ahead and just see how we can change this to be back to a task, and then it should return a to-do detail, which will obviously automatically just import that. And then I'm going to say to-do list, and this is going to be of type list of to-dos like that. And I think the other one was to add to do, which was literally just, this one can just return a void and then accept a to do detail like that. Oh, we can use a keyword like that, and then the delete to do, which is going to just accept a to do ID of type string, and that's it. So get, add and delete. I'm not going to really add the update one because it will kind of follow the very same pattern. I'll say go to its implementation. Right now it will be screaming that we add the implementation for this guy. So I'm going to say implement the interface, which means import all the things that it wants and make sure that we can just add the functionalities for it. Great. Since we said this ITodoService will be using a memory cache to simulate how the database would look like, then let's go ahead and add a constructor. You just type CTOR and then press enter, and then it will add this constructor. I would like to import the iMemory cache in here and then say memory cache like that. And I mean, remember, we need to have a private read-only of type memory cache, and then we just make sure we assign the memory cache within our constructor. So then now this memory cache is ready for us to use it. So for the add to do, it's going to be very, very simple. It's just going to be iMemoryCache dot set. Then we can say it requires a key and an object. So in my case, I would just say the key will be the key of to do. Then we say ID, and then the value will be the to do. It's saying because ID may be now sometime. Good. Now you can see that this method is complaining because obviously this is supposed to be async. Async task like that. And I mean, it's saying these async methods likes await and all those kind of things. So for us to simulate as if we are going into the database and there's other calls being done, we can just say await.task, and then we can just delay by a second. So obviously this will just to show that as if we are going to the database. I mean, just so that we can have some waiting time for that. And then the delete one will definitely be looking something similar to this, but then the difference will be, I think there is remove, and then you just have to go and remove a specific ID. Don't mind these errors. So I'm going to say async like that. So it's going to be an async task to do that, and then I'm just going to delay it so that we can see this in action. So then if we want to get this to do, I'm going to say if the memory cache dot try get value, I mean, we have some sort of an ID, and then we want it to return a to do like that, then we can go ahead and return the to do just like that. Just make sure that we add the async beforehand. The let's then await operator. Let's make it wait for a second. I think this one is gonna be saying not all path returns that. And then we can go ahead and return maybe null. Just need to make sure that this is of type to do, and then it should be able to return that. Converting null literal or possible null to non-nullable type. It's not the best way to go, so let's just say that is that. Null, and then out to be a to do, and then that is it. So this should work, right? So, and I mean, if we want to get a list of these guys, then we can just go ahead and say create a list of to do list, and then to do list is equals to new type of that, and then we can go and call this method get to do, and then let's say the first ID was 1, like that, and then let's say we have 2 other ones as well. 3, 2. Let's await for all of these different calls. And here we need to just say async, and that is it. So we can go ahead and is.add, and we edit just like that. I'm just going to duplicate these, remove this 2, update the IDs accordingly, and that is it. This should work somehow. And then you obviously then just need to return this to-do list that we have, and this should work. This probably might not be the most smartest way you can go about it. I mean, you can simplify your code by doing something like that. Just make sure you remove the trailing comma there. Then you can just edit like this. I mean, in real world projects, you probably don't have to be going to get it to do one by one like this. In a database, you just go and say select all, and then it will probably bring back a list that you can easily manage in a nice way. But let's assume our database right now it's this complex, and we just need to go and get one by one until we are sorted. Now, if we go back to our controller, you will see that our endpoint is failing. So let's just go ahead and remove that and uncomment the code we had, and just make sure that now we add things accordingly. So the first one was saying it needs a list of to-dos. So you can just await, call to-do.service, and then get to-do list like that. And it should be able to work. Return type of that. Async task of that type. Need to say list. No, task. Segments of that. I mean, we just need to remove that required param, because in a to-do list we don't really need any ID. We go to its implementation as well. We go ahead and remove this ID because it was never used. Make sure you save the file, both the files. Then if you go back to the controller, everything is actually fine. So I mean, we can do the very same thing into get to do by ID, and then we paste the method like that. Obviously, make sure you call the get to do, and then you can go ahead and pass in the ID. Make sure you update these things accordingly. You ensure that we are returning a task of type to do details. You see now it's no longer complaining, which is great. I mean, to post, it's literally the very same thing as add to do, and then you can go ahead and pass in the to do that you would like to post. And I would add that like that, remove the void. There's no return. You can just do that. Or if you wish to return the to do you added, you can do that accordingly. The put will literally be the same thing. The page, the same thing, but I'm interested in the delete in this case. I mean, you can play around on how you're gonna go about put, which is firstly you go and get the details and then update it and then set it back and then return. But for now, I'm gonna worry about the delete, which will be something like this. I need to just make sure that I have an async task. I remove the void, delete to do, and it's literally that operation. So now we have added 3 implementations or 4 implementations of this to go and get a single to do, get a list, and also add a new to do, and then delete. So let's go ahead and start our API and see how it's going to behave. If I refresh this, it should be having the latest. Let's give it a second. Oh yeah, perfect. It was able to do the right thing. So when I try it out, I'm going to add the 2 Jan 2024. Let's say the description is, this is the first to do. The title, let's say it's title 1, like that. I'm just gonna copy this and then save, execute. It looks like everything was okay. It was a success. And then I'm going to add another one. It's going to be of type of ID2, another one of ID3. Because remember, we kind of hard coded a lot of things that side. But I mean, if you wanted them to be dynamic, you can do it that way. But right now, if we go and try to get a list of everything we saved that side, we just have to go and call the get of to do, and then you can see it goes and fetch everything there. But let's say we needed a specific one with an ID2, and then to get something of ID2, then we can just go ahead and you'll see it will get. If we try to get something of the ID that doesn't exist, well, it'll probably just returned an empty thing. So I'm gonna just get something that exists there. So yeah, that's it. We saw how we can use dependency injection and use interfaces to only expose the functionalities we want to expose them. And we also checked how we can use a MemCache to store our data in the meantime, until obviously we go and explore our databases. So that is it for this episode. See you on the next one. Cheers.